Hello and welcome everybody. Today we're going to be going over linear measure. So our goal from the end of this is going to be able to define line segments, congruent segments, and start using some algebra to calculate segment lengths. So to start off today, we want to ground what we're doing and why it's important and why it's something that's real. So this is a running website that I sometimes use to map runs or walks that I go on. And you'll notice here, this is our building. So this is our campus where we're at. And the reason why this is important is because during remote time, they want teachers to be able to take their masks off. So in order to do that, we have to be in an enclosed office space. So basically both doors shut, we're the only person in the room. Otherwise, masks are on 100% of the time that we're in here. That sounds like an easy thing to do because you'd think, okay, most teachers have their classrooms, they can just stay in their classrooms. But because of our cohort model, we rotate through classrooms and we don't each have our own space. And actually, there's usually one or two less spaces than teachers. So what that ended up with is a situation where Mr. Reardon, myself, and Mr. Hinklin didn't have any room in the academics. So one of your assistant principals, Mr. Herzog, found us a space right here. And it is actually a closet in the power line lab. It is nice, though. It has electricity and air conditioning and lights and things like that. Nonetheless, it's all the way over there. So if you are familiar with campus, you'll know that this is the farthest end of the building. So in order for Mr. Reardon to walk back to the academic space, it takes about 2 or 3 minutes. So we can actually measure this out using our GPS map and some line segments to see, is Mr. Reardon just complaining unnecessarily about a really long walk, or is there some real distance? So let's start it out. So we start here. We start walking back towards the commons. We go here. Okay, so what this GPS is telling us, you can see it in the bottom left corner, from Mr. Reardon's closet just to the commons where you'd normally eat lunch under normal circumstances is 0.12 miles. So a little bit over 1/10 of a mile. Okay, but the commons aren't all the way back to cohort 3's academic space, so he's got to keep walking. And that's actually pretty close to the end of the building. So if we look at this total walk from the classroom where Mr. Reardon would normally teach to his closet/office in the power line lab, it's actually 0.19 miles, according to our GPS here. So a couple things that we can notice before we move on are, one, these are not lines. They do not extend indefinitely. They are segments of a line. So they have endpoints, right? It's not an infinite distance. We can measure it. It's 0.19 miles that he has to walk. And two, we're seeing here, if we just drew lines on this page, it wouldn't really mean anything. I mean, it'd be a good visual, but it wouldn't mean anything without actually having the distance of the measure there. So now, if Mr. Reardon and Mr. Hinklin want to submit a formal complaint, they can say, I have to walk 0.19 miles, which maybe is a good thing. Maybe we could use the exercise, but that's the idea, and that's an application of using line segments and the measure of line segments to something in real daily life. All right, so let's get into today's lesson. So with that being said, we are going to jump into our first definition. And our first definition is going to be line segment. And we are going to define line segment as a line with two definitive endpoints. And if you would, let's underline endpoints because that is the big difference. So if you want to look at an example, line segment, the points are the ends. It does not extend beyond A and B. The way that we would write this is a set of arrows on top, just a line on top of AB. So I'll put segment here. A line, which is different from a line segment, I put line, that has the arrows that extend. So again, it still could be points A and B, except the difference is that it extends. So these are two different things between line and line segment. So notes for this, a line segment, or just segment for shorthand, is a measurable part of a line that consists of 2 points. We call them end points. all of the points in between. So let's say if like there was a point like P in the middle, P is in between A and B. It's part of that segment that we're measuring here. And again, we can measure it because it's finite, right? It stops. If it goes on forever, it's impossible to measure. The length would be forever and forever and forever for this one. So can measure segment, cannot measure line. So two different things. All right, next, a segment with endpoints AB can either be named AB or BA, so you are allowed to switch the order. And the length or measure of this segment, we just write it as AB without the line on top. So if you're ever wondering, can I just write AB without a line on top? It is different than saying segment AB. It's actually talking to like a calculation of the measure of AB. So important distinction there. All right, so let's do a little bit of practice here. So on our bottom, so this should be the bottom of page 1, we're going to just draw two segments. So I'll draw the first segment, and then we can get started with the second segment. I'll let you practice that one on your own. So we're looking for 42 millimeters. This is a centimeter ruler. So if you ever need a quick conversion, just know that 10 millimeters equals 1 centimeter. So we'll start off with an end point at 0. And then if we calculate that out, this is 10 millimeters, 20, 30, 40, and then let's find 1, 2, be right there. So those are the two endpoints. They want it to be LM, so let's label it L and M. It could be M and L, doesn't matter which way, and then we'll connect it. So again, between these 2 points, it does not keep going. That does not happen. Okay, it stopped just between those two. We can say the finite measure is 42 millimeters. The next example, QR, should be a little bit more straightforward. It is centimeters, and this is a centimeter ruler. So the idea is that we would just have two endpoints, and it would be 5 centimeters long. Any questions on that, please let me know.